Hi. In this poster, we look at the Sierra Nevada Great Valley region in California. Here, we're looking from the southwest, so here's the Sierra Nevada, this is the Great Valley. Outstanding questions in these regions are what causes the uplift of the Sierra, and what is the nature of the high-velocity Isabella mantle anomaly. A branch of the literature says the Sierra's lithosphere foundered, leading to subsequent uplift. Other imaging studies infer the mantle anomaly to be a fossil slab remnant, and some studies interpret the anomaly to be a combination of both. In this study, we use two types of observations. The first is seismicity from the ANSS catalog, which has this interesting deep crustal band shown in blue. This is well south of any current subduction. The second type is receiver functions with azimuthal harmonic behavior that tells us about rock fabric at depth. We see some interesting behavior at the stations marked here in yellow. We'll look at each type of observation on the next few slides. First, seismicity. Here is the band of deep earthquakes. The orange dots are 30-kilometer or deeper events. They are right under the western Sierran foothills. The San Andreas is over here. The orange dots without a black border are pre-2000 locations. These deep ones close to the San Andreas are Coralinga event aftershocks and stop appearing in the 2000s. In contrast, the foothills line is seen into the present day. On the zoomed map on the right, they are color-coded with depth. You can see they go to almost 50 kilometers depth. We're going to look at the across-strike cross-sections marked by these lines next. Here we are going across the deep band in each panel, with the panels arranged from north to south. West is on the left. The events are now colored by year. The really deep ones are magnitude 2 to 3. 2-ish is the detection threshold down there. You can see a hint of a V-shaped pattern with the deep band at the center. These are plotted with a 1-to-1 aspect ratio. Now moving on to receiver functions. A bunch of stations in the southern Sierra have an interesting feature. Here is one example station. These are receiver functions stacked by event back azimuth. The radial component average is in green and yellow and tells us about contrast in isotropic flat layers. So here's the MOHO, the transverse component, and the azimuthally varying part of the radial component can be used in an azimuthal degree 1 fit to find contrasts in dipping rock fabric, shown here as the red and blue trace on top. You can see a peak at the MOHO and another one right below it. The azimuth of these positive arrival maximum gives us the foliation dip sense. We can also tell that this is not just signal from a dipping MOHO by looking for polarity reversed similar amplitude arrival at 0 delay time, which is not present here. A model that matches these observations is sketched on the right. It's a layer with west dipping fabric sitting right underneath the MOHO. This shear sense matches a scenario where the lithosphere was sheared off to the west. On the left map, we see the stations that have a first harmonic arrival at the MOHO. The arrow length is the amplitude. The color is depth. The black tick points down dip, and it is to the west for most stations. The right map shows the arrival right below it. Only the Sierra stations have it, and the tick points up dip to the east at most stations. Our overall interpretation is on the right. The southern shear layer inferred from receiver functions, maybe from prior delamination of lithosphere. There is no deep seismicity here. The deep seismicity to the north might indicate incipient or ongoing lithospheric removal in that area. Thanks for watching. For discussion and questions, please leave a comment and find us in the Zoom room.